Hello everyone, welcome to my Signals and Systems video lecture 5. So today we will discuss about discrete time unit impulse signals, discrete time unit step signals, signals as a combination of standard signals like step, impulse, etc., system with memory and memoryless system, invertibility and inverse system, causality, stability, and time invariance. So let's start. So first, discrete time unit impulse signal. So it is expressed by del of n within third bracket is equal to 1. So what is del? Why the n is inside the third bracket, and what does equal to 1 means? Let's see. So del means impulse response. So in signals and systems, whenever we will see in future del, we will understand that it is indicating impulse response. Okay, and n within third bracket means discrete time. Okay, and when n is within first bracket, it will mean continuous time. Equal to 1 means the magnitude of this function is 1, that is unit. That is why it is called unit step. It is called unit impulse response. Okay, discrete time unit impulse response. So what's the definition of impulse response? So impulse means nothing but sudden force. Okay, so for example, you are putting a nail, embedding a nail in a surface or a wall with the help of a hammer. So when you are forcing the nail inside the wall, you are giving the nail input impulse force. Okay, and that sudden force is impulse in nature. Okay, and it looks like this. Okay, so when somebody puts a nail inside wall or surface, he repeatedly gives it impulse inputs. Okay, so that's one example, but we can find a lot of examples throughout nature of this response. Okay, so the equation that denotes the impulse response, okay, is del is equal to 0 for n not is equal to 0, and del is equal to 1 for n is equal to 0. So the value of del is 1 only at 0, and for other values the value is 0. So 1 for 0 and 0 for others. Okay, so time shifted discrete time unit impulse. So previously in the picture we have seen that magnitude of unit impulse is 1 only at 0, but when we are talking about time shifted discrete time unit impulse, we are talking about impulse response such as this del of n minus k, where n is 1, 2, 3, 0. Okay, so in this case del is equal to 0 for n not is equal to k, and when n is equal to k, the value of del is 1. Next we have, okay, so I have seen students getting confused between del of 0 and del is equal to 0. So let's clarify that. Okay, so they are different. Del of 0 is not equal to del is equal to 0. Okay, basically when we are saying that del is equal to 0, it means previously I have seen del is equal to 1, and for other values it was 0. So in this case del has no value, okay, even not at 0 position. So del is equal to 0 for all the values here. So the magnitude of del is 0. But when we are talking about del of 0, we are talking about the value of n on the x-axis. Okay, so del is equal to 0 means we are talking about y-axis, but in this case we are talking about x-axis. Alright, so del of 0 means value of n is 0, and n is similar to t. In continuous time domain we have seen t, and in this case as we can see del of 0 is equal to 1. So here is another example of time shifted discrete time unit impulse. Okay, so continuous time unit step. Okay, so look at these two pictures. This is discrete time unit step, okay, and this is continuous time unit step. So when we are taking samples of this continuous time unit step at an interval, okay, then we will get signal like this, and this is called discrete time unit step. So what's the equation for discrete time unit step? So as impulse response were expressed with del, the step response is expressed with u of n, which is within third bracket because it is discrete signal, is equal to 0 for n less than 0 and 1 for n greater than or equal to 0. So what it is saying is that it only has value which is 1 for 0 and greater than 0, and other values are 0. Okay, as we can see from the above picture. So step as a sum of multiple time shifted impulses. So we can express step response as a combination, as a summation of multiple impulse response signals, okay, which are time shifted. So let's see. So this is a unit impulse response and which is discrete in nature, and this is del of n. Okay, now in this case the signal is time shifted and it can be mathematically expressed as del of n minus 1. Next we have another signal which is again time shifted but different from previous two. Actually it has a magnitude of 1, okay, or can have any magnitude at n is equal to 2, and it is expressed as del of n minus 2 and so on up to infinity. So these values, so values like this, we start adding these values, okay, and we will get signal like this. So let's watch again. So this is del n minus 2, this is del n minus 1, and this is del of n, and when we add signal like this we will get a step response. Okay, so we can say that summation of del n minus k, where k is 0 to infinity, because previously we have seen k is 0, k is n, okay, and n minus 1, that is why it was turning into del of n minus 1. Okay, so we have seen that k has values 0, 1, 2, 3 and etc. up to infinity. So this is discrete time unit step, and del of n plus del of n minus 1 plus del of n minus 2. Okay, so let's go back to continuous time domain. So in continuous time domain, impulse and step can be expressed as a function of each other. It can also be expressed in discrete time domain, but for now let's talk about continuous time domain. So any unit response can be expressed as a integration, because in case of discrete, integration is similar to, in discrete time we say summation, and in continuous time we say integration. Okay, and the unit response can be expressed as a integration of unit impulse responses. Okay, and unit impulse can be expressed as a derivation of unit step response. So here we can see there is a signal, example signal, and we will express it as a combination of standard signals that we have learned so far. So if we, so this is u of t, and if we subtract this, okay, this is a time shifted unit response, and if we subtract this from this, we will get this. Okay, so for subtraction we will use 1 minus, so the whole equation will be u of t minus u of t minus 1. So we can again express this signal as a combination of standard signals. So that would be your homework. Write down the answer in the comment section. So let's talk about system with memory and memoryless system. So what is a memoryless system? A memoryless system is output dependent only on present input, such as register. Okay, so a register is a memoryless system because it does not store energy. So the values or properties of the register, that is voltage or current through it, is only dependent on the current value of those properties like voltage and current. Okay, so here we can see a mathematical expression which itself is a memoryless system. So y of n is a memoryless system because all the output, that is y of n, which is the output, is dependent on the input, which is not time shifted. If it were system with memory, we could have seen n minus 1 in this equation, but there is no n minus 1 or n plus 1. We are only seeing n, 2 into x of n and x square n. So there is only n and no n minus 1 or plus 1. So this is a memoryless system. So in system with memory, system with memory stores information of input other than present time. Okay, and information can be in form of energy as well, like inductor, capacitor. Okay, so capacitor stores voltage, which can also be expressed as information. Okay, and delay signal, the system which delay input signals or accumulator. Okay, this kind of devices are system with memory. Let's see what is invertibility and inverse system. So we can determine input from output in inverse system. Okay, for every unique input, output must be unique as well. So what is that? Let's see in an example. So let's take an example of an equation y is equal to 2 plus x into 0. So whatever the value of x is, the output is always 2. Sorry for the last equation, it should not be 3, it should be 2. Okay, is a mistake, it should be 2. Okay, so here we can see that this is not a inverse system, because if we are given the output 2 and the system, we would not be able to determine what was the input. Okay, but if we are given y is equal to 2x and we are given output 6, we can easily determine that x was 3. That is why y is equal to 2 into x is equal to 2 into 3 is equal to 6. Okay, so y is equal to 2x is inverse system, but y is equal to 2 plus x into 0 is not. Okay, so in non-inverse system, the output cannot be determined from input and the system itself. So what are the applications of inverse systems? So in communication system, like for encoder and decoder, we use inverse systems, equations which are inverse in nature, for encoding and decoding purpose. Okay, like encoding and decoding is done in communication for multiple purposes, like encrypting the input message so that anyone in between the sender and receiver cannot understand what is being sent. Okay, and detecting error during transmission, so we can create a lossless system. Okay, an error free system. Next we have causal system or non-anticipative system. So in a causal system, output depends on present and past input. For example, a simple series RC circuit. Okay, and mathematically the below equation is an example of causal system. Okay, so here n means x of n means we are counting the value of present, and x of n plus 1 means we are counting the value of past. Okay, because this is a time shifted input. So let's talk about stability. So what is a stable system? Stable system is any system where we give some small input but it does not divert the system from its output. For example, a pendulum is oscillating at a certain time period or a certain frequency, and we give it a small force. So this small force won't divert the oscillation. Okay, and even if it does, it will again get back to its previous position soon. Okay, so mathematically example of unstable system is exponential signal. So y is equal to e to the power x is example of an unstable system, because with increase in value of x, the system keeps increasing. Another example of unstable system is positive feedback system. How? Let's see. So in this positive feedback system, we can see that input is given to a system and output is being generated, and part of this output is again being fed to the input. Okay, and this summation here, the accumulator, whatever we call it, okay, this will create the input to the system would be summation of previous output or part of the previous output plus input. So it will increase continually, and the output would be something like this. Next, time invariance system. So System characteristics and behavior is fixed over time in case of time invariant system. Okay, so suppose we have a RC circuit with us, and if the value of R and C does not change over time, we can say that it is a time invariant system. So what are the mathematical properties of time invariant system? So time shift in input result in identical time shift in output. So what is this? Let's see. For discrete system, suppose in a system we are giving input x of n and we are getting output y of n. Then if in the same system we give input x of n minus t, t is the delay in time, then the output should be y of n minus t. And in case of continuous system, if x of n is input and y of n, or x of t and y of t are input and output, then x of n minus t and is applied when in the system, in the continuous system, the output should be y of n minus t. Okay, so let's see an example problem. So find if y of t is equal to sine mod of x of t is time invariant system or not. So y of t is, as mentioned, sine mod x of t. So y1 of t is sine x1 of t, and x2 of t is equal to x2 t minus m. Okay, so this should be x1 t minus m. Sorry for that. It should be x1 t minus m. Okay, so that should be 1 instead of 2. So y2 would be sine x2 of t mod, of course, and x2 of t is x1 t minus m. And if we give y1 t minus m, we see the value is sine x1 t minus m. Okay, so with change in input, we have delayed the system by m time, and the output is delayed by m time as well. So it is a time invariant system. So with this we end module 1, introduction to signal system. Thank you.